probability and expected value, which will be an important topic for the 2024 exam, as this was taken out in the previous 2 years. So they'll be sure to want to put something on this in 2024. So part A says calculate the expected value of costs. The cost is for £10,000 and expected value means the value multiplied by the probability of this event happening. So we need to find the probability that there is a delay. So one way of doing this is with a probability tree diagram. This starts at the left side and it goes either two ways. One is the members of staff falls ill and the other way is that they don't. 0.3 probability that they do, 0.7 probability that they don't. Now once that's happened, then we look at the equipment failure and there'll be a 0.1 probability that the equipment fails, so a 0.9 probability that it does not fail, and this is the same in both branches. So now we can find the probability for each of these combinations of events. So what about the key member of staff falling ill and there being an equipment failure? Well, that will be 0.3 multiplied by 0.1, so a 0.03 chance of that. And likewise we can do this for the other combinations of events. Now what we want to do is work out the probability of a failure or a failure or a member of staff falling ill. And that's the only way that they get a delay. So we need to see which ones we need to add up. We need to add up those three because the first one, the ill and the failure, so both of those mean there's a delay. And the second one, the 0.27, there isn't a failure but they are ill, so they're still delayed. And likewise for the 0.07, the equipment fails even though the person wasn't ill. So we need to add up 0.03, 0.27 and 0.07 and we will get 0.37. The clever way of doing this would have been to have worked out the 0.7 times 0.9 to get 0.63. That's the probability of there not being a delay, and then do 1 minus 0.63. Now to finish this, we need to do 0.37 multiplied by the £10,000. So the expected value is £3,700. In part B we have these so-called control measures, which are options that we could take to avoid these problems happening, but it means it'll cost more money. So if we spend £1,000, we can avoid this problem of people being ill. We can get replacement staff. Control measure 2, we spend £3,000 in advance, and that means we can rely on the equipment. So we want the expected value of all of the costs if we take control measure 1. So there is this extra cost of £1,000. Now we also still have the chance that there will be a delay and we'd be charged £10,000, but this time this is no longer happening for unwell staff. It can only, because we've taken measures to control that. The only thing left over is the delay, is the damage to the equipment failure, which we saw before was a 0.1 probability. So we have to add on 0.1 multiplied by 10,000. So this will be 2,000 expected value for measure 1. So now on part C, state which control measures should be taken. and it tells you that the expected value for control measure 2 is £6,000. So we can compare the three numbers, 3,700, 2,000 and 6,000, and we can see that the lower of all of those, the least of those, is £2,000. So that's for control measure 1. So you would state control measure 1, and that's because the £2,000 is less than £6,000, also less than £3,700 if we didn't take any control measures. Now, something that's not really discussed in the marking scheme, so I don't know if you'd have to mention it or not, is the possibility of taking both control measures. So if you took control measure 1 and control measure 2, you can see that 1,000 plus 3,000 is £4,000. So even with that possibility, the £4,000 is still greater than £2,000. So it would still be only control measure 1 that should be taken.